shit. Integer. Oh, integer. The primitive data type comprising of negative and positive numbers and 0. With a size of assigned 32 bits, meaning one of the bits is dedicated to the int being either assigned a negative or positive value. The rest of the 31 bits allows the user, to compute mathematical values as large as 2,147,483,600. Just 2 to the power 31 inclusive, and don't be a silly Billy. Forget that it's signed. So you could also use negative 2 to the power 31. Remember, if a bit value is given, just put that bit value over the 2. So 2 to the power that bit value. Don't worry if you haven't obtained the. I'm gonna scrap this part. And I'm gonna stop sounding pretentious. Okay, let's get right into it. Take notes. We're going to get into the big int. If you didn't understand that stuff, revise on your knowledge of primitive data types. Also, I'll probably make a video for data types soon, you know? Okay, let's get right into the big int. The big int. Now, what if 2 to the power 31 signed size isn't good enough? Now you might be asking, well, what is that for? When am I going to use such large values? They're not something you account on a daily basis, even in your math classes. So you would use it in something like competitive program, but you're competitive program, I'm talking about a job. What am I using the job? Cryptography, your security stuff, cybersecurity, that stuff. It's useful. There's other examples, but I can't name them from the top of my head. I don't work in them. But just as the name big int implies, it allows you to store very big integers. Now, any astute observers noticing the screen of my many examples would notice that the instantiation process for a big int uses question marks in the parameter, similar to strings. In fact, you pretty much have a string in the parameter. Now, before you start pointing things out and making conclusions, hold those horses right there. Let's first go over what a big int is. It's technically a reference data type instead of primitive because it's a class that you could directly make objects out of. It's not a primitive data type where you gotta do the auto-buxing. If you want to know, how do they hold these crazy values? Why can the primitive data types do it? Why can the reference data types hold these big values? Now, I'm gonna have to ask you to hold your horses again, because let's go over why the string is a parameter in the first place. Why there's a string parameter in the first place. Does that mean big int is just a string class? Is it a string? Is it the string representation of an int? Is that what it is? I mean, it has some string methods. So is it the same thing? I'm gonna let Kanye West answer this question.
You madness.
The answer is no. That's just a string representation that's used as a parameter to not limit the possible size of the big int. Because if they used, let's say the parameter was an int, a numeric literal, so even a long, it would be super limited to just that. But think about it. Think about how many characters you could type into a string. You would be it's almost endless. Well, it's not. You got a specific memory for that, but that memory is way bigger than your numeric literals. Think about how many text-based games are made in Java. They wouldn't be able to hold so many characters if the string could hold as much as a numeric literal. Like visual novels, they would be pretty much gone. Or at least people wouldn't be using Java for them. Well, to be fair, most people aren't. Most people are using like RenPy and other engines. But let's say people were making visual novels out of Java. Yeah, they wouldn't exist. And Freddy over here wouldn't be able to sink his 76,167 hours in a game about raising up anthropomorphic Catwoman at a questionable age.
Embarrassing!
BigInt accepts a string as a parameter, but you can't put any characters into that. You can't put any letters or anything like that. It only could be a number or a plus or minus sign. If you put a letter in a blank space, you will get a number format exception. Hence, it won't work. Now, if you want to use the BigInt in your code, first you gotta, well, import it. And the BigInt is part of the math class. Remember that? That's basically the superclass for the BigInt. So, before you start typing away at your code, import java.math BigInteger. I know I keep calling it BigInt, but the real name, the full name is BigInteger. And since BigInteger is, well, I'm going to call it BigInt, is a class, that means you're going to have some cool methods. But before we get into those cool methods, we haven't talked about operators. Now, I know you have your like basic operators that you use for integers. Your multiplying, your dividing, your subtraction, your addition, and your modulus. But you can't just directly use that for BigInteger, as it's an object. You can't just be like adding objects together. That's not how it works. That's why instead you have to use specific methods for just the object. So you would be using BigInt object dot add BigInt object inside of the parentheses, and then for subtract it would be BigInt object dot subtract, and then in the parentheses BigInt object, and then multiply BigInt object dot multiply BigInt object, and then divide BigInt object dot divide BigInt object. And in each of these methods, you can only put a BigInt object into the argument. I meant as the argument. Now, you might be wondering if there's a possible way of converting the int to a BigInt. Well, BigInteger class already got you covered, because there's some conversion methods. So you could use, this is not an object, this is just a class itself. The class itself, BigInteger dot value of int val. Now, what is this for? This is to convert the int value you see in the argument int val. That's the int we want to convert to a BigInt, and the value, the output of that is, well, a BigInt. Or we could use it. See, this one has object BigInt object dot int value. That one converts the BigInteger object over there to an int value. Or even, let's say we want to get a string out of the BigInteger object. BigInt object dot toString. We get a string, an actual string representation of the BigInt object. Now, if we made now I'm a terrible speaker. If we made the BigInt object dot toString and then made it equal to a string variable, then you could use all the string methods you want, because that's, well, an actual string. So just to show you an example of using these conversion types, If we had a normal int and we wanted to multiply by big int, it would look like this. You would have big int object dot multiply big integer dot value of int value. It's really just simple. All of this also means that if you want to multiply a small value like 1, you would have to create a big int with a value of 1 or convert an int to a big int. Actually, there's a shortcut for this. Like, normally you have to create an object or just do conversions, but there is some static fields in BigInteger that allows us to just directly call the constants of 0, 1, and 10. So you don't have to actually create an object, you could just directly have 0, 1, and 10 ready to go. So you just be using BigInteger, that's the class, dot 0, full capital, and then full caps, or BigInteger dot 1 or BigInteger dot 10. Notice that they're all capital because they're constants, and that's like a proper way to like organize it, differentiate the constants from the other variables that are like changing all over the place. And that's like the proper way to do it. So that's like a great way to start practicing it. But let's say the 0, 1, and 10 constants are from the BigInteger class aren't enough. Like, we need like a 2, we need a 5. Let's say we have to do that. You want to assign a value to a variable, pretty much, and you don't want to do that multiple times because it'll just be super repetitive. So instead of just assigning it on the top as BigInteger then variable equals the new BigInteger, instead you could just directly put it into the method like this: object BigInt dot add new BigInteger, and then inside we put the value that we want. And this is just completely fine. We could just put it inside the method, and that's like a way faster way of doing it, and we don't have to. If we're just using something that's just one-off, like you're just going to abandon it, you're just going to abandon that big integer, then you don't have to assign it to a variable, you could just directly put it there. Now the final method we'll go over, and note that there's way more methods than this, but this is all that this is the main stuff we're going over in this video, is the negate method. And I'll just show you an example. So we have BigInteger value, well, val equals new BigInteger, and then we have 2. Val equals to val.negate, and then we print out val. Now the output you get is -2, and it creates a negative, and that shows what it is. You just create a negative version of the existing BigInt. Oh, what an excellent opportunity to transition to immutability and BigInt. Well, BigInt is immutable. Now, immutability means that any changes caused by, let's say, methods would only be seen if the original object, like the original value, is pretty much scrapped and replaced. So in our example before, we had BigInteger val equals new BigInteger 2, where we assigned the 2 to val. Now that will be scrapped when we do val equals val.negate, because that's the same exact name and it'll be the same exact name in the memory. So pretty much that object's being scrapped for an object of the new value. And you pretty much can't change the value of the original object. So that means that the original value is going to go to the Java garbage collector because it's an inaccessible variable and it's being replaced by a new variable when we made val equal to val.negate. Because, well, 2 and 2, not 2 and 2, 2 and negative 2 are completely different values. Let's put this in simpler terms. Like, that was a little all over the place. Immutability only allows a value to have one value. When it's forced to take on a new value, though, through an object of the same name equaling a different value, that will mean that the new object, which has the same name, mind you, will pretty much take its place. It's like the episode where SpongeBob thought he was an imposter or something. Was that the episode? Yeah. Damn, I do not remember that. It was like when SpongeBob lost his identity or whatever. You know, I'm losing my identity right now. I'm so damn sleepy. Anyway, I'll break down immutability in another video. And let me just like stop recording.